Hey guys, this is our presentation on Decorator Patterns by Trent, Luke, and Suzanne.
Okay, so first starting off, what is a decorator pattern? What distinguishes it from other patterns? And the answer to that is that a decorator pattern allows additional responsibilities to be attached to an object during runtime. This essentially allows for enhancement or addition to occur to objects dynamically without changing the object itself centrally. Okay, so next, what are the components that make a decorator pattern work? So the first and foremost is the pattern needs an interface to utilize as the base for the entire object. This is essential because it allows at runtime for the object to be changed. Second, it needs a core non-optional component. This is the part that acts as the center of the object and keeps its essential signature together. To add on to the core piece, we utilize an abstract wrapper and derived optional classes that add on to our core. The example I have here on the screen is making pancakes. Our interface would be the pancake itself at the very top of our chart, because the object itself is a pancake. The core, which is the two on the left, as labeled core, is a wheat or white pancake. It's important to note that you can only choose one core type, but you can have multiple cores to choose from. Once a core is selected, it can't be changed during runtime. Next, to enhance our pancakes, we use an abstract wrapper class called toppings. It doesn't change anything internally about our pancake core, but instead it adds or it decorates onto our core. This does so, as in our pancakes example, by adding toppings onto our pancake. We do this by utilizing, it does this by making a wrapper inside itself, which wraps the original class and keeps its signature intact. It then calls the new derived class of the toppings underneath to add addition to our core. You can think of this as making a new pancake, but then adding on whatever topping needs to be added and keeping this new pancakes and topping together. And this allows for more toppings to be put on, as many as you want, and not changing the core class, but instead just adding on to it.
So after learning a little bit about the decorator pattern, what it is and how it works, I'd like to talk about how we could use the decorator pattern inside of our LDS teaching app. One example that I thought of was our notifications. So we have different kinds of notifications. We have the reminder for after we schedule an appointment, it pop up and remind us. And we have our scheduling. So when we schedule it, say, hey, here's what you just scheduled. And we also have the preferences part of the class, which will decide what will actually notify us and what we want blocked out, what we don't. So what I thought of was the actual messages, and I thought about making that an interface. And when that's an interface, we have the reminder and the scheduling part of that and they are allowed to decorate the message, if you will, and do whatever we want with it. So the difference between subclassing is when we use subclassing, different subclasses extend a class in a different way, but an extension is bound to the class at compile time, and it can't be changed at runtime. So using this, our notifications, they can be changed at runtime and as the days progress. So as I was briefly talking about subclassing and inheritance, when you're using it, it can become too lengthy and complex to add multiple features and behaviors. However, using the interface has a lot more flexibility, and it'll give us a lot more options, and we can do whatever we really want with them, and we can decorate the notification how we want to. And this is just one example of the many ways we could use this inside of our home teaching app that we are making together.
Decorator patterns are super useful and have a lot of upsides. One upside is that the decorator pattern provides a more flexible way to add responsibilities to a class than by using inheritance. This is because it can add these responsibilities to selected instances of the class. It also allows you to customize a class without creating subclasses high in the inheritance hierarchy. Another upside to note is that decorators allow behavior modification at runtime rather than going back into existing code and making changes. They are a nice solution to permutation issues because you can wrap a component with any number of decorators that you find necessary. The decorator pattern supports the principle that classes should be open for extension but closed for modification. So decorator patterns are super useful and have a lot of upsides, but they also have some downsides. One is that decorators can lead to a system with lots of little objects that all look alike to the programmer trying to maintain the code. This can end up being a maintenance headache for anyone trying to look at the code. Second, a decorator and its enclosed component are not identical. Therefore, that means that tests for object types will most likely fail. Decorators can cause issues if the client relies heavily on the component's concrete type. Decorators can also complicate the process of instantiating the component because you not only have to instantiate the component, but you also have to wrap it in a number of decorators. The next thing we want to know is when to use decorator patterns. So we have a few different options. We should use decorator patterns when we want to add responsibilities to individual objects dynamically, but we don't want to affect other objects in our code. We also would use decorator patterns for responsibilities that can be withdrawn. Or we would use it when extension by subclassing is impractical. Sometimes a large number of independent extensions are possible and would produce an explosion of subclasses to support every combination, or class definition may be hidden or otherwise unavailable for subclassing. Thanks for watching our presentation on decorator patterns. We hope you learned a lot and do well on the test.